All right, let's go. AI for humans, and this is episode 4. Let's talk about models, okay? And they're actually a lot more common than you might think. A lot of people mention models today, and this is going to be like the core of this episode. Models are constantly used everywhere. You hear things like the model predicted this, we trained a new model, or you'd actually hear stuff like ChatGPT is a language model. Actually, the idea of LLMs are large language models. So, what exactly are these models, and how exactly do models work for us to be able to actually get the full intuition of it? I remember we said that in this episode is going to be a very, very small breakdown. So, this is the core in terms of its idea, but in terms of implementation, it's a lot more complicated. But think of it like the core in terms of idea. So think of it like a model is everything that the machine has learned packed into a file. So this is our machine and this is our model. So the model is everything that the machine would learn, everything we are going to feed to the machine, right? Everything we feed to the machine, we put it in a file. This file is the model. Now, I hope that is clear. So what we are essentially saying is that everything that we are going to be showing the machine, everything the machine is going to be learning from, and pay attention that this is not data, just data. This is learning. So remember we earlier said that for machines to learn, they have to use what we call try and error. So the entire try and error process would be stored in a file, and this file is going to be given to the machine. So initially we had said that we feed the machine with examples. So remember we used jollof rice and we said we feed the machine with jollof rice, jollof rice, jollof rice. Yes, but that's not exactly how we feed it. We load this data into a model. So all the data will come into this file, right? All the learning will happen in this file, and then the file will be fed to the machine. So what exactly do we mean by this? Now pay attention to this. My mom is a chef. My mom is a caterer. She caters for events. She's not a chef. So my mom is a caterer, and ever since I was young, I've always known her to have something that she called a recipe book. So in that book, she used to write. She writes her recipes for different meals. And every time she had a new job, she would always write the recipe, like the list of things that she wants to cook for the clients. So maybe it's rice, beans, all of that. It's always in the recipe book. Now, let's imagine that you are a chef and your recipe book is just about making eggs. Now, remember, this is the goal, making eggs, right? Good. This is the goal. And as a chef, you constantly have been making these eggs for over 20 years, right? And over the course of 20 years, year one, when you started making the eggs, you made the mistake of adding too much salt. In year two, you made the mistake of adding too much pepper, right? But as at year two, you already knew the amount of salt you should add, but now you added too much pepper. I know a year is a long time, but just follow the idea. In year three, you added too much sauce, and year four, so many mistakes. But as at year 10, you got perfect eggs, right? Perfect eggs. Now, perfect eggs, and by year 15, you even made the recipe much, much better. And by year 20, you had like aced it. You were the egg master. So now you created a recipe book for eggs, telling us this is the amount of salt you should add, this is the amount of pepper, this is the amount of Maggi, this is the amount of curry that you should add to your eggs. Nobody adds curry to eggs, but this is the idea. You have a recipe book full of eggs. Now, the idea is this. Every time the chef decides to cook eggs or make eggs, right? The chef would not go and start making eggs from year one again, the same method they used in year number one, and add so much salt and then oh, sorry, not too much salt, and then add pepper again. It won't do that all over again. All the chef will just do is go to the recipe book and say, oh, from the recipe book, I'm supposed to add this amount of salt. I'm supposed to add this amount of pepper. I'm supposed to add this amount of curry and all of that. Now, the idea is the recipe book is the model. So it follows the model, right? The chef follows the model. He looks at it opens to the page where there are eggs, it follows the model, and then it works that way. AI models actually work the same way. So remember we said we train it in with a lot of examples. So we tell the AI model 2 plus 2, and this is just examples. 2 plus 2 is 4, 4 plus 4 is 8, A plus B, you cannot add it, and so on and so forth. And we save all of this in a book. And we call this a model, right? And it's not a book, in a file, right? This file is a model. So whenever we ask a question from the model, from the ChatGPT, from Anthropic, what happens is that let's say your ChatGPT goes and checks its model and it tries to find the answer. When it finds the answer, it returns the answer to you, the user. Everything that is happening there is happening through a model. Okay? Simple and straight. Now, what is actually inside your model, right? Right? We said learnings, but what exactly do we store in this file, in this book? That is very important. And that's the core of models. This is where it actually gets very interesting, right? Just pay attention. Actually, the only thing that is stored in these models are numbers, lots of numbers, all right? Lots of numbers, millions of numbers, sometimes billions of numbers. And each number is called a weight. So let me write that. So the model stores numbers. Each number is called a weight. And I promise you by the end of this video, you understand what the weight is doing. Now, what exactly is the weight? So I'm telling you that if you look into a model, like if you ever had a chance to look into a model, all you'd be seeing are numbers like 0.4, 0.76, 0.8, right? If you see them in vectors like this, 0.2, 0.9, right? And these are weights. We call these things weights, right? You can see they are denoted sometimes with W1, W2. So what exactly is a weight? A weight is the connection between two ideas. How strongly connected or how loosely connected they are. So weight is the connection between two ideas. And this connection can either be a strong connection or a weak connection. Okay? A weight can either be a strong connection or a weak connection. So let me give you a very good example, and this should drive you home. What happens in model training is this. Let's start from the top. We said we train models, we train LLMs, which are the models, on data. And then it will look at the data and it will create connections based on that. So let's imagine that in our data, every time the word fire is mentioned, another word hot is always found with it. All right. Every time the word fire is mentioned, another word hot is always found with it. For example, the fire is hot, right? The fire burnt down the building and the structures were very hot, right? Hot systems go through fiery connections. You get the point. Fire and hot are two very common statements, two very common words that go pari passu. There's a tendency of every time you see the word fire, a very high percentage of the time that you see the word fire, you see the word hot. So if we train the model on 1 million documents, right? And in all of these 1 million documents, 700,000 of them, 700K documents, have the word fire and hot in the same sentence. In the same sentence, the model would create a very high weight. Remember, we said the weight is the connection between two words. High weight between both words. So it means that the model would say, okay, fire, what was that thing in mathematics? We used to do it then. Proportional. Yes, we could say fire is, let's say, directly proportional to hot. This is not the sign of proportionality. I'm just saying there's a connection, right? Right, fire and hot. Now, on the flip side, let's say the weight for this will be 0.8. We only measure between 0 to 1. So 0.8 means it's on the high side, right? The weight between fire and hot is on the high side. On the flip side, if the model sees words like fire and ice cream, fire and ice cream, the weight for this can be something like 0.05. And this is just arbitrary, 0.05, which means very low connection between both words. Very low connection between both words. And that's the idea, right, of weights. So models have their weights, and the weights tell us how strongly connected two words are going. Now, this is the interesting part, and this is where I actually want you to build a. It doesn't get more complicated than this in hindsight. And if you understand this, you'd be like in the top 1% of people that understand AI. So I'm giving you interesting information. When you go to ChatGPT, you say, okay, let's go to, give me a moment, can be acting up lately. Let's go to chat.com and you ask a question. I'm going to build you a workflow for you to see what is happening behind the scenes. You see, in the beginning, when ChatGPT was created on something we call a lot of documents, right? So these are documents 1, document 2, document 3, document 4, document 5, document 6, that's right? These are the docs. Okay. ChatGPT was giving so many documents, your books, Harry Potter books, your mathematics textbooks. So just so you know how it is getting all the answers, your mathematics textbooks, your whatever it is, ChatGPT was giving so many documents. And what it did was it studied. Now, the machine studied the documents. This is the process of learning. So it studied. I remember we said learning, right? It studied the documents. So every time, how did it study documents? It looked through them and it created weights as per connection of words. So it looked at every word in the document and it looked at what were the next words. What are those words that are very connected with those words? And it sees those things over and over and over again. So every time, let's imagine that it looked at the word boy and it noticed that across, if it was given 1 million documents, 1, 2, 3, 4, 5, 6, 7, out of these 7, it noticed that every time the word boy was mentioned, in 5 of these documents, the word girl followed through. Every time boy was mentioned, girl was mentioned. But in these other 2 documents, every time boy was mentioned, girl was not mentioned. What does this mean? It means that there is a high connection between the word boy and girl. Now, if we will do this over and over and over and over and over again across many words, like we had the example of fire, maybe it has words like rice, it has words like Nigeria, it will check how many words, what are those words that are closely connected with Nigeria, right? And then it would create weights between these words. It will create weights between these words. Now, stay with me. It is very complicated because I am just explaining the concept of one word with another word, but it does this across thousands or even millions of words. So it can check how many million words are actually connected to boy. Maybe boy is also connected to man. Boy is also connected to guy. Boy is also connected to G. Boy is also connected to bro. And it will create weight. So you can say, okay, 0.8 for boy and girl, maybe for man 0.7, for guy 0.6, for G 0.4, for bro 0.9. This is telling me that I've seen boy and bro so many times connected, right? I've seen them connected so many times, so I can actually give the very high weights, high connection, high weights. But for boy and G, and not a lot of times, so low connection, low weights. Now, all of these things it learned, what will it do next? It will then save what it has learned. It will save everything that it has learned in a file. And this file is the model. In this file, the system would now say boy, girl, weight 0.8, boy, man, weight 0.7, boy, G, weight 0.4. Now, pay attention. Pay attention to this, okay? Every time, and remember I said he's doing it across the opposite of across a couple of words. So maybe every time he saw boy and girl, he also saw the word opposites. It will weight that as well. Maybe when he time he saw boy and man, a boy is maybe the word mature. It will also give mature a weight, right? That links these words together. This is what is in the model. This is the model. And this model is the brain. This model is what we now feed into ChatGPT, and GPT will now hold it and say, okay, good. Whenever you ask ChatGPT a question and you say, I have a question, and ChatGPT says, okay, give me your question. Okay, I am on charts.com. And I say, who is a boy? ChatGPT does not go to the data to look for answers. No, it doesn't do that. That's not where it goes. It does not go to the connections that it made during learning. Nope, it doesn't do that. It goes way to the model. And then it says, okay, this person has asked me who is a boy. And it's a lot more complicated than this, but I'm giving you very, very deep intuition so that you can get the idea. And he asked me, who is a boy? ChatGPT would then say, great. Now I need to know the word boy is related to what? It will go into the model, it will check, and then it will come out and tell you, based on all the connection that it has made, a boy is a young man. I'm not saying this is the correct answer. I'm just giving you an intuition. He is the opposite of a girl. Some call him bro. Do you understand what is happening here? Now, let us actually go to ChatGPT, right, and actually ask this. Like, let's just do a bit of like a practice section so you can see the idea of what we are saying here and why. Remember, pay attention to what we are actually building here is that the weight is important. It has created a high weight between boy, man, boy, girl, boy, bro. So you will not see it say things like a boy is a king, because it has not seen a lot of situations where boy and king have been paired together. This is very, very rare. It doesn't notice such. The weight between boy and king might be very low, 0.2, compared to the weight between boy and maybe and boy and girl. Now remember, of course, that we could, if we expanded this question and said, who is a boy in the palace? Palace changes everything, right? Because Palace now would have to influence this. And I don't want us to go too deep, but think of it just on the basics, right? The weight is what it uses to find the answers to your questions. Okay, now let's ask the question here. Who is a boy? Look at the beauty of ChatGPT's response, right? Who is a boy? And you see, a boy is a male child or young male human, usually referring to someone who hasn't reached adulthood yet, right? This can describe a young male person from infancy through teenage years. informal use. Some people also call shut up. People also call adult males boys in a casual or friendly way, the boys, but the core meaning is still about the youth. So do you see the power of weights, right? So it has assigned a very high weight between boy and male and young and human, right? And it does the same thing here where like, okay, if he's a boy, he must be teenager because those words must have been really connected. So boy, teenager, and you can also see males. And the idea, okay, boy, youth. So the idea here is very simple, right? It has assigned weights based on all of the data that it has learned so far on using all the data it has learned so far between boy and man and guy and bro, right? It goes into the model where all those weights are saved, and it uses that information to be able to give you a response. So when you ask who is a boy, and imagine my answer was like a boy is a young man, right? So that connection is really in sync, right? So a model is the brain, right? It's well, let's not call it a brain, right? In this case, in hindsight, it's the brain, but it's not actually the brain in deep perspective. Okay, it's just a very large collection of numbers that has patterns, weights learned from data, and the weights can show high connection or very low connection between words, like the boy and the man, and then the boy and the girl. Okay, now next episode we're going to talk about how do we set weights, and we're going to explain with a very, very simple example, right? I don't know if this episode was really simple, but if you think it was actually very simple, you could share with someone who you think would definitely love to see how ChatGPT is working behind the scenes. So now, whenever you ask a question to ChatGPT and you see the answers, try to see if you can catch the weights. At least just look at the connection between the words, and then you have an intuition into how AI is actually working. See ya on the next episode.